Moving on to example 5 in applications of rational expressions. We're talking about a little bit more complicated example. So Jaylene's car uses 10 gallons of gasoline to travel 210 miles. She has 5 gallons of gasoline in the car. She still needs to drive 640 miles. If the car continues to use gasoline at the same rate, how many more gallons will she need? First thing we always do with these problems is we read and we're making sure we dissect the information. So if it gives you values, make sure we're using these values. Okay, and we're discarding anything that we don't need. But in this case, we're going to use all of these. Next, we're going to assign a variable. This is something that we want to find, and it is very explicit in what we need to find. How many more gallons will she need? So clearly, our variable is going to be gallons. Last up, we are going to set up and solve. So we are going to set up and solve. So let's put in what we know. So there's a couple ways to do this problem. I'm going to use mostly ratios, but if you use a different method, it doesn't necessarily mean it's wrong. Okay, so we already know that she goes 210 miles using 10 gallons. And usually cars, they talk about their miles per gallon. So that's kind of the format we use there. Now, because it's the same car, it's going to be equal to a different trip. Remember, this is like her first trip. So her second trip should have the same proportion, same ratio of miles to gallon because it's the same car. Unless she modified her car in some way, it's going to be the same. Okay, so that's why we can set these two equal to each other. That's why this chapter is called rational expressions, because we're talking about ratios. Now, we already know she goes 610 miles. Okay, and she starts with 5 gallons. And it says, how many more gallons will she need? Well, clearly, if she goes 210 using 10, then she's not going to go the whole 610 using only 5. So we need to add to the number of gallons. How many gallons do we need to add? We don't know. So we should call it X. And that's what we do. Now, there's a process we can do. We can multiply both sides of the equation by the same thing to get rid of the denominators. But in this case, it's actually pretty easy to just cross-multiply. There's actually an even easier way that we can do, and we can first simplify this. If you can simplify 210 divided by 10, go ahead and do it. So 210 divided by 10 is 21. So her car gets 21 miles per gallon. And we know this is equal to 610 divided by 5 plus x. Now this looks like a little bit easier of a problem to deal with. What do we do next? Well, we're going to multiply both sides by the denominator to get rid of it. Multiply both sides by 5 plus x. So what happens? Well, we distribute, multiply both terms. We get 21 times 5 plus x equals 610, and it's going to cancel in the top and bottom. So we're just left with the 610. We still need to distribute and solve for x. So we get 21 times 5, which is 105, plus 21x equals 610. Subtract 105 from both sides. 21x equals 535. Final step, divide by 21, and we get x equals, let me go over to my calculator. I type in 535 divided by 21, and I get 25.48 gallons. Make sure you include the unit. Okay, so that's how we do a problem like that. Moving on to a little bit harder of an example, but not impossible. Also, feel free to pause at any time so you can catch up with the notes. Amelia and Matt are walking to their gate at the airport at the same rate. Amelia uses the moving sidewalk and Matt doesn't. If the moving sidewalk moves at 1 meter per second and Amelia saves 50 seconds and the distance is 300 meters, what are both their moving rates? Obviously, no one would actually be doing a problem like this, but if you were in a business and you had to calculate certain things with moving parts or industry and some of your automated processes, you definitely would. Now, the process is similar to both. So 300 and 300 is the distance, the same distance. Now, if Matt's unknown rate is x, Amelia is going 1 meter per second faster. Okay, rate equals distance divided by time. Distance is a measure of meters. Time is a measure of seconds. So meters per second. We add 1 meter per second, so it's x plus 1 for Amelia. Matt still stays at x. Time is where it gets a little tricky. Now, we could use a new variable. We could say t minus, or t for Matt, for his time, but remember, Amelia's faster, so hers would be t minus 50. The problem is now we have multiple variables. So there's a couple different ways to do this. I think the easiest way to do it is to solve time in regard to x for both of them. Let me show you how to do it. So the first thing we're going to do is we are going to rearrange the rate times distance formula for t. So we want t, we want time. So we need to solve for time. How do we do that? Multiply both sides by t. tr equals d divided by r, divided by r. Time equals the distance divided by the rate. And that makes sense. If someone ran 100 meters and their rate was 10 meters per second, how fast did they run it? They ran it in 10 seconds. Okay, so that's a way we can solve this problem in regard to x and for their time. So we're going to show how to do that right